All right, we are starting lesson 19, Introduction to Quadrilaterals. We will start with the review to ignite your previous knowledge. So we have a vocabulary, a polygon with all angles and all sides congruent is, so all angles, if you remember that from previous times, is equiangular. And all sides is equilateral. So if we have something that is both equiangular and equilateral, that means that it is a regular polygon. So number 2, we're going back to vocabulary again, and it's a four-sided polygon is called A, and it's already given to us right here in quadrilateral. Question number 3 is asking us to identify the figures at the right as a square, a rectangle, or neither. So if we start off with a square is a regular quadrilateral. So that means we have both angles and sides the same. Here we do see that each of the angles are the same. However, if we look at the sides, we are only told that these two sides are the same, and without knowing that another one of those sides is the same, we cannot call it a square. We cannot call it an equilateral quadrilateral, so it's not a square. But for a rectangle, all we need for a rectangle is it to be an equiangular quadrilateral. We do have an equiangular quadrilateral, so that means this is a rectangle. So question number 4 is multiple guess. We have the interior angles of a square are, and now we want to read from D to A because it says right here on D, all of the above. That means that if we have if we have 2 answers that are correct, we know that it's D. And if we get one answer that we know is not correct, then we know it is not D. And it is whatever the correct answer. So we have all of the above is an option. So C says convert the corresponding exterior angles. So let's mark up this because we know it is a square. We know that all of the angles are the same. They are all right angles. So now if we have a corresponding exterior angle, so this exterior angle here, well, we know that it is a linear pair because two lines come together, two angles come together to make a line. So for this, we know that this angle is a right angle because the supplementary to a right angle is a right angle. So we know that it is congruent to the corresponding exterior angle. So C might be our answer. Once again, we don't know if it's D yet because we need, if answer B is correct, then we know it's D. But if answer B is not correct, then we know we have the answer of C. That's why it's so powerful to go from the back to the front. So here we have congruent to each other. So that is saying that it is equiangular. Well, we just talked about how it is equiangular. So that means the answer has, because the answer can be C and B. The answer is D. Now for this slide, it does have a table like one that we had before, which was good to put in your notes, but we want to hold off on adding this to our notes quite yet until we talk about a caveat that we will have in a little bit. So a quadrilateral is a polygon with 4 sides. Quadrilaterals are classified according to the number of congruent and parallel sides they have. So a quadrilateral is a parallelogram if both pairs of opposite sides are parallel. So that means this top and bottom are parallel to each other, and this side and that side are parallel to each other. It also has a parallelogram also has that this side is congruent to this side and that side. There's just a little bit more markup that we can do to make it so we know that. A kite has 2 pairs of consecutive sides are congruent, and this is one that we'll have to talk about a little bit later. And a trapezoid is 1 pair of opposite sides are parallel. We're going to need to talk about that later. A trapezium is that no sides are parallel. So a trapezium is kind of the opposite of a trapezoid. So now if we look at the reason we couldn't copy down this thing directly out of the book, the table out of the book, is because of the standard. The standards are what we as teachers need to make sure that you understand by the time you leave our class. And 9.3.3.7 discusses that down here. It says, for example, recognize that a rectangle is a special case of trapezoid. So that means that we can't have exactly one, because exactly one means we have one and no more. But if we're talking about a rectangle, so this side is parallel to that, which means, okay, yep, we got a trapezoid, but because of the definition that is given by the book, that these two cannot be parallel. But because the standard directly says that it is, we need to get rid of this exactly. So that means that the answer key that we have in the that is online will probably not say trapezoid or rectangles, but it is something we need that needs to happen. And right here, kite, we also need to get rid of that. The other example is actually to give a concise and clear definition of a kite. So what we want to do here is we want to concise means small and compact, and clear means that it is obvious to everyone. So if we have, if you explain it, it is going to be clear to everybody. So here we have, if you've ever bought a kite or flown a kite, you probably have seen something kind of like this, and this is a kite. Now the kite that you fly is a little bit different in that it has a tail, and most popular depictions has a little bow on there or two. For it to be a mathematical kite, you do not need the tail or the bow. We also have, in addition to the quadrilaterals listed above, there are three types of parallelograms. This is parallelograms and trapezoids. And actually around this is, we'll get into that a little bit later. So parallelograms are classified based on whether or not their sides are congruent, or whether or not they have right angles. That is, whether or not they are, whether or not their sides are congruent makes it a equilateral, and whether or not they have right angles makes it equiangular. So a rectangle is a parallelogram with four right angles. This is equiangular, and we have two sets of congruent sides. Our top and bottom are congruent, our left and right are congruent. A rhombus is a parallelogram with four congruent sides. So this is our equiangular, or equilateral, sorry. This is our equilateral quadrilateral. A square is a parallelogram with four right angles, so it's angular, and four congruent sides, that is equilateral. So when you are learning something, it is typically a good idea to look at whatever you're trying to do in a graphic organizer. So this is a way of doing that. So this is a graphic organizer for the quadrilaterals. So here, quadrilateral is anything with four sides. So there are two main areas that quadrilaterals fit into, and then I have an arrow going directly to kite because it's kind of there. A trapezoid has one pair, or has at least one pair of parallel sides. So that means this top one is parallel to the bottom one. And a trapezium has no parallel sides. So if we look at the trapezium I drew up here, that is not, none of those sides are parallel. Now I have a darker gray arrow going from trapezium to kite because most of the time when you call something a kite, it is not going to be able to be any lower on the square or on this graph than you do. So if you see something and you say that is clearly a kite, that is a kite, it is a trapezium because the sides are not congruent. How are not parallel, sorry. But if the sides are in fact parallel, then it creates this trapezoid connection and it becomes a rhombus. So most of the time a kite is a trapezium. If you say, yep, that's a kite. If you can say that's a rhombus, then that is not a kite. So a trapezoid, where if we keep having these sides and they go and they go and they go and they go, and eventually it ends up being a parallelogram where we have this side and this side are parallel, and this side and this side are parallel. So these kites, this rhombus, all four sides are the same, so that the kite, or a rhombus is kind of a combination of that parallelogram and kite, where we have the sides the same, but the angles aren't necessarily the same. Once again, you would probably call a rhombus. You wouldn't call a rhombus a parallelogram. You wouldn't call it a kite. So if you're going to talk about something, you would specifically say that's a rhombus as opposed to a kite. So rhombus is obviously connected to the trapezoid, not the trapezium. A rectangle is if we have our parallelogram and we straighten out the two sides, so we have all of the angles are the same. And that's there. All four, the two pairs of top, bottom, left, and right are congruent. In a square, we have all four sides are the same and all the angles are different. Or all, sorry, are the same. It is a regular. It is a regular quadrilateral. Whereas this one, we have the angles are not the same. Difference between a square and a rhombus. Some quadrilaterals can be named in several ways. For example, a square is also a rectangle, a rhombus, and a parallelogram. A kite is also a trapezium. So classify each quadrilateral, give multiple names if possible. So here, because we just have the information that the two sides are parallel, it is a parallelogram. And then it would also be a rhombus. I like this blue color, so let's use that for this one. So this we have that this side is congruent to that side, and this side is congruent to that side. So we have two pairs of congruent sides. That is a sets of congruent sides. That means that this is and because none of the sides are parallel, it is a trapezium as well. Let's change this to this teal color maybe. That won't show up. Let's try. We have KL and M that are parallel. We have a set of parallels. That means it is and now we can pick a different color, so this one or this last one. We know that our angles are all the same, but we don't know anything beyond that. That means this is a rectangle. That is the tightest circle that we can get. Then beyond that is a parallelogram. And it is also a trapezoid. So it says classify the quadrilateral, give as many names as, give multiple names if possible. So if we look, we have all four sides are the same, but not the angles. We aren't told anything about the angles. So that means it is a rhombus. Well, we know that a rhombus is a combination of a kite and a parallelogram. And that it is also a trapezoid. So this is the end of part 1.